The Sun has the potential to release solar flares 1,000 times greater than previously recorded, which can rattle the Earth's communications and energy systems, said researchers. Led by University of Warwick in Britain, the research has found a stellar superflare on a star observed by NASA's Kepler Space Telescope with wave patterns similar to those that have been observed in solar flares. Our solar system is filled with plasma or ionic gas, originating from the Sun as a result of the solar wind and other more violent solar eruptions, such as solar flares. Stars very similar to the Sun have been observed to produce enormous flares, called superflares. To give us a better indication of whether the Sun could produce a catastrophic superflare, we need to determine whether the same physical processes are responsible for both stellar superflares and solar flares, explained lead researcher Chloe Pugh from the university's Center for Fusion, Space and Astrophysics. Found in the Milky Way, the binary star known as KIC 9655129, is known to superflare. The researchers suggested due to the similarities between the superflare on KIC 9655129 and the Sun's solar flares, the underlying physics of the flares might be the same, supporting the idea that our Sun could also produce a superflare. Typical solar flares can have energy equivalent to a 100 million megaton bombs, but a superflare on the Sun could release energy equivalent to a billion megaton bombs. If the Sun were to produce a superflare, it would be disastrous for life on Earth. Our GPS and radio communication systems could be severely disrupted and there could be large-scale power blackouts as a result of strong electrical currents being induced in power grids, Pugh informed. There are an indication that the same physical processes are involved in both solar flares and stellar superflares. The finding supports the hypothesis that the Sun is able to produce a potentially devastating superflare, noted the study published in the Astrophysical Journal Letters.